I'm Hilary, and I'm going to talk about the rise of the data scientist. But before I get into that, how many people here have heard that term before? All right, not very many. That's great. I realize that I'm the only thing standing between you and a coffee break. So I will keep this fairly brief. So I'm the chief scientist at Bitly, and if you don't know Bitly, we are a platform for sharing URLs on social networks. And so if you use Twitter or Facebook and you see all those nice little short URLs with hashes, that's us. We power about 25,000 different domains and see about 80 million unique pieces of content a day, and somewhere around 300 million clicks on that content. We actually fetch all that content and process it. And the idea behind Bitly was always that it was the data that made Bitly interesting. In fact, the idea of a URL shortener being a company is kind of mind-blowing. I mean, it's kind of a dumb thing. That is an interesting thing only because of the data exhaust that we gather. So that's the perspective that I'm going to speak to you from. I'm not actually going to talk about Bitly very much today at all. There are a lot of buzzwords right now around data. We heard some of them earlier in Werner's talk. Big data in particular, I'd like to say we're not going to talk about that because it doesn't matter how big it is. I really don't care how big your data is. We will focus not just on cloud data, but on data science. And this idea that we can build systems that learn things from data easily. So data scientists are people in your organization that do three things. And the first one is that they build mathematical models of the data. And by that, I mean they build models in the same way physicists build models. There exists some system in that data that they want to understand. It is not something that's pure math. In fact, instead of pure math and applied math, we usually say it's applied math and just math. They design systems, so it's non-trivial to process large amounts of data, and that means you have to have a certain amount of engineering and infrastructure knowledge and capability. But most importantly, they are the people who understand your business well enough to ask the right questions and to know what exists in the data that can be immediately used to optimize over some function that actually creates meaningful results quickly. And this has to be the good questions. And there are a few reasons this is happening right now. In 2012, the first one is the availability of CPU and infrastructure, both the existence of database technologies, but also the ability for anyone to spin up a supercomputer for essentially no money, which has two effects. The first one is that it brings the capability to people who have never had it before, and the second is that it lets you experiment. And the most important thing about that is that you can ask the question and get the result before you've forgotten why you asked that question in the first place. There are algorithms so we finally understand what to do with our data. And the last piece is the data itself, of course, is so cheap to gather that we all have it. It's piling up and we don't know really what to do with it yet. So who are these people? They are people that blend four main disciplines, that is engineering, infrastructure, computer science, mathematics, and curiosity. They may come from the social sciences, and that's actually a good thing. They are nerds. And when we look in the center of that, we find really awesome nerds. And just to give one example, this is one of my favorite images. It's a candle burning down over 15 hours. So each frame here is one data point. You might naively think that if you were to graph this, without really thinking about what it looks like, you might draw a straight line, thinking the candle's burning linearly over time. But when you look at this image, it's immediately clear what the model is. Everybody understands it. And that's what a data scientist does. They find these sorts of functions that everyone can understand out of that data. And you tend to find them in academic institutions. Disaffected academics make great data scientists. There is a trick, though, to building the structure of an organization around your data scientists. In fact, this is the most common question I'm asked by executives at larger companies, which is, I've got my chief scientist, he's got a 12-page CV, what do I do now? Right? So how do you think about building the company such that your chief scientist will succeed. And there are really two main schools of thought, which I've illustrated with toys for you. So here's your data scientist, and you can put them in the middle, and this might be a team, by the way. You can put them in the middle of your product, your business, and your analytics team, so they can sit in the middle and talk to everybody, and then go off and find some results and bring it back. This is the model we use at Bitly. This is the model you find at smaller companies, mostly because there's generally just one person with this capability. But it is a model that's been used fairly well at companies like Twitter as well. The other model is this. You farm people on your team out to the different products that they serve. This is the model Facebook uses, and depending on your focus, can be very successful. Then they move around from team to team. So I want to give you a few examples of things people have done recently with data. And of course, we have to talk about the obvious companies. So Google has been a data company from the beginning, perhaps the first big data company. They didn't need to change any of their culture in order to build effective data teams. Facebook also is a data company, though somewhat slower to realize it. In fact, their data team mostly focused on things like ad targeting. Before they realized there was a huge amount of human impact that was possible from the data they have. And lots of traditional companies are also starting to get into this. I'll get back to that though. I wanted to show you an example. This is a published graph. It is a reinterpretation of the fantastic data visualization of Napoleon from the OkCupid blog. If you have not seen this, please Google it right now. It's blog.okcupid.com. This is an example of a company that has taken a data set. They're a dating site, a free dating site. It's very popular among hip young people. And they created a marketing arm out of their data. They also use that at the request of clients to find interesting correlations about products and people's dating behaviors. Another dating site I've worked with uses their data to maximize subscriptions, and they're able to tell you exactly what percentage of women versus men you need to have in a city of what size, at what rate of growth to get people to subscribe optimally. Another example I wanted to share was a major US drug company, a pharmacy company, who built a predictive model of their competitors' store opening locations. So they went back historically over 15 years and figured out exactly where their competitors were opening stores, such that they could predict future store openings, and then they went and got all the spots first. Thought that one was pretty clever. And this is one that we collaborated on at Bitly. So this is a map we did with Forbes, showing the relative influence of US media publications within the United States. And you learn a few things here. So for example, people actually buy USA Today, who are not in hotels. We see Fox News in Texas, and NPR in Oregon, and The Onion in Wisconsin, which makes quite a lot of sense. The Onion is from Wisconsin. But I've included this because one of the most common applications we see when people combine their data with external data is benchmarking. So every company wants to know, compared to my competitors, how am I doing? And the last thing I wanted to give you, in case your afternoon was in a bit of a lull, the cutest kitten clicked on the active social internet last year. This is something we calculated at Bitly from approximately 80 million clicks. So the dirty little secret here is that most of the really good data work happening now is just counting things. Sometimes counting them cleverly, but as much as we talk about fancy math and machine learning algorithms, and indeed I've spent most of my life studying both of those things, the truth is that we're still getting a data set into a form where we can just sort of iterate through it and count something and then apply that to whatever real problem we're trying to solve. And that's the first challenge. That is, how do we get beyond counting? The second one is that big data is big. So at Bitly, and to be honest, we're not the biggest of the big data. We've had to spend a month just copying our data from one system to another. That is just watching it go down the pipe. And I know you can take a hard drive and mail it to Werner's house and it'll show up in the Amazon cloud. They do actually offer that service. That's not just a joke. But the data is getting so big that we're finding that you have to move the compute to the data. And that sort of changes the way you think about your data center and your data center strategy entirely. And timeliness is another factor. We would say real time is big time. Getting your data into a place where you can ask a question of it and get the response quickly is important. Some of the systems that are becoming very popular right now, like Hadoop, are not designed for real-time interrogation. This is a huge hole in the current data landscape. And the last one is visualization. So this is a visualization of global risk from a very complicated data set done for the World Economic Forum by Morten Stefaner, who's a brilliant data artist. But the ability to take something very complicated and n-dimensional and render it in a form that any human being can understand quickly and can study and then learn to apply to whatever problem they're trying to solve is a very difficult skill, and the tools for doing this robustly are still largely missing. Most of the people working in the data visualization space are brilliant hackers. They shouldn't have to be. So to sum up, I'd like to end with a few thoughts. The first one is that data science is not actually new. It is just taking capabilities that have existed for a very long time in different silos and combining them in one individual or in one team. And it is changing the way companies are built. New companies like Bitly exist because of this, but it's also changing the way old companies do business. And that's it. I'm Hilary Mason on Twitter and H@Bitly if you'd like to talk about it further. Thank you.